Notice the difference between the two cases. So now we need to find the derivative of t with respect to x. So you write dt over dx. When you differentiate tan, you get sec squared. Sec squared, that is of x over 2, then times derivative of x over 2, which is 1 over 2. So, but you know sec squared can also be written as 1 plus tan squared. So this can be written as 1 over 2 into 1 plus tan squared of x over 2. And you know tan x over 2 is t, so we want tan squared of x over 2, so we square that, that will be t squared. So this thing can now be written as 1 over 2 times 1 plus t squared. So I want to make dx the subject. So you can say therefore, in this case, our dx will be equal to 2 dt over 1 plus t squared. That is if you cross multiply and make dx the subject. So that is another substitution, because I told you once you make a substitution, you must also know the corresponding differential. So we are going to substitute this one that I've ticked and also this other one, those two. Now, we also need to know what is sine x in terms of t and what is cos x in terms of t. Already we have found the x in terms of t. So as we are substituting, we must know what is sine x and what is cos x. So we are going to get those using t is equals to tan x over 2. The easiest way is to draw a triangle. Draw a triangle, or of course right angle triangle. This one. Our theta, our angle theta, in this case is x over 2. Our angle is x over 2. We put it there. X over 2. So remember, tan x over 2 is equals to t. T can be written as t over 1. So that we know the opposite and adjacent, because tan is opposite over adjacent. So the opposite will be t, adjacent is 1. So using Pythagoras theorem, I can get the hypotenuse. Remember, hypotenuse squared is the same as the base squared plus the height squared. So that will give us, now we want hypotenuse, you take the square root on both sides. So that will give us 1 square root of 1 plus t squared. Now, from our triangle, it is now easy to get sine x over 2. We can read it straight away from the triangle, that sine x over 2. Remember SOHCAHTOA, that is opposite over hypotenuse. So opposite is t, hypotenuse is the square root of 1 plus t squared. I also need cos x over 2. Cos x over 2 from that triangle is adjacent, which is 1, over hypotenuse, which is the square root of 1 plus t squared. So now that we know sine x over 2 and cos x over 2, are we able to find sine x and cos x? Yes, we are going to use trigonometric identities. So you can write this, that sine x can be written as sine of, let me use a different color, x over 2 plus x over 2. Sine x over 2 plus x over 2. Remember, I want us to take note. I'll write it up here. Let me use a different color for the note. Remember here that we can write NB. We know that sine A plus B is the same as sine A cos B plus cos A sine B. That's an identity. Another one, we also know that cosine of A plus B is the same as cos A cos B minus sine A sine B. So these identities are very important for us. They are very, very important. So this note is very important. We are going to use these two identities. One of them will help us expand sine x over 2 plus x over 2. So let's use the first identity to expand sine x over 2 plus x over 2. So what do we get? That will give us, I'll write here equal to, so remember it is sine A cos B, so that will give us sine x over 2 cos x over 2, then plus cos squared. So that is sine x in terms of t. So you can just say sine x should now give us 2t in the numerator and 1 plus t squared in the denominator. So similarly, let us see how to find cos x in terms of t. You want to express cos x in terms of t, so what you do, you break it down into x over 2, of course cosine of x over 2 plus another x over 2. So let me write, we'll write similarly, we need cos x. How can we write this? This is the same as writing cos x over 2 plus x over 2. And when you use identity number 2, let me take it. The first one was for sine A plus B. If we use the identity for cosine A plus B, this will give us cos x over 2 times cos another x over 2 sine x over 2 times another sine x over 2. And so you can say this is the same as cosine squared of x over 2 minus sine squared of x over 2. And if I substitute, they are going to get, for the cosine we got 1 over the square root of 1 plus t squared, and the all of this one should be squared, then minus, for the sine we got t over the root of 1 plus t squared. Again, the all of this should be squared. So when you work out that, that will give us